Good evening all. We'll start the symposium in a short while. Good evening, everyone. Good evening, everyone. Welcome to the PMRF Symposium 2021, organized by Department of Civil Engineering, IIT Madras. We have 30 plus presentations from the PMRF scholars in the coming 5 days. To begin the event, I invite Professor Manu Santhanam, HOD of Department of Civil Engineering, to give the inaugural address.
Thank you, Anupama, and a very warm evening and welcome to the PMRF Symposium, the first of its kind conducted in our Department of Civil Engineering. I am Manu Santhanam, Professor and Head of the Department of Civil Engineering. Ours is one of the oldest departments of the Institute with a rich legacy and a very active research program. This program is considered amongst the best in the country. Our department hosts more than 300 PhD scholars, out of which 30 or more than 30 are actually supported by the Prime Minister's Research Fellowship, which is a flagship program initiated by the Ministry of Education 4 years ago. Over the next 5 days, you'll see our PMRF research scholars give a glimpse of the exciting work that they are involved in. The schedule every day includes research from diverse fields, including geotechnical engineering, structural engineering, building materials, water resources, environmental engineering, and so on. The discussions are certainly expected to be very engaging. So I request you all to please stay on, participate in the discussions, and encourage our bright young minds. So welcome once again. Thank you very much, and Jai Hind. Over to you, Anupam.
Thank you, sir. So the symposium goes like this. We'll play the recorded video of each PMRF scholar, and your queries can be entered in the chat box. Also, after each presentation, if you have queries, you can unmute yourself and ask the queries. We'll also put the questions from the YouTube. So today we have 5 presenters. We have 6 presenters. So we'll start with the first one. It is Shantanu Bhattacharjee.
Good morning, everyone. I'm going to present my talk on aspects of buildability in extrusion-based concrete 3D printing. Material parameters that govern this. We'll start with understanding what are the critical parameters and what is the motivation behind this study. So we start with what is the motivation behind 3D printing. First is housing crisis. So we can solve a big housing crisis using an automated process where mass house can be built continuously, and the demand is going to rise with time, and we can fulfill the demand using this technology. Next is the digitalization process. with this era of digitalization where everything is getting digitized, even construction industries needed to get digitized. This 3D printing is a part of it where it integrates the digital and physical processes. So we can say that in one hand we have the automation, and other hand we have construction itself. So it's a important is in that. Now the third is improving quality control and saving cost, and introducing freeform shapes, which is good for architecture and other purposes. Now we come with the criticality parameters while we are printing it. So this is a typical 3D printer that we use. We pump the material through this uh, pipe from a pumping system. Then the next important property that comes is to extrude it, and it should uh, be, or it should have the shape in which it is extruded. It should not deform while we are extruding it. It should not be flow like a water. It should hold its shape. The next is buildability. That is the ability to sustain loads while printing, and it is critical again because when we are printing layer by layer, the structure should not deform away from the planned or the designed diagram or the design plan that we have made. It should not deviate out from there while printing it because of the deformations during printing. And then last thing is the automation. That is obviously the basis of 3D printing. These are the main things, and with this we connect the structural performance and how to assess the structural performance, how a layered structure, a heterogeneous structure is going to perform, and how to incorporate sustainability in terms of binders, in terms of the design itself, and to reduce the to stand and to take the load of the subsequent layers. Next is to how to define the buildability. So how to say that, or how to quantify it, how to define it, that what is buildability. Uh, Then how to measure the structural strength, and how to create the representative polymetric elements, which should we study the hollow cylinders, we should form the walls elements, we should follow the masonry codes, we should follow the concrete codes. We don't know at this moment. How to increase the structural integrity of the 3D printed structures, how to increase the integrity. Should not have voids, it should not have failure planes, failure fissures, and all these things. And at the end, obviously, how to make it sustainable and green, since this technology has the potential to become green. So this is a typical structure where you can see that layers are getting printed one over another. While doing this, we have a small interface where the two layers bond together, and it is basically a heterogeneous structures having a solid material and a weak bond. You can see that the bond is weak here, and you can see it. So this is the structure how it forms. We can see that it's a part of a wall which you have cut out, and you can see the layers and layers and bonds, and there are voids between two layers which is horizontally placed to each other. So this is what the heterogeneity and from where the research questions come. Now what is the objective of the study, of my study basically, is to develop a framework for the assessment of the buildability of a printable mix, considering the material and the geometrical factors, and to create quantitative parameters for buildability micro and macro scale. It's a lot of work, so you will understand it where we go for the deliverables and the work done. So the first deliverable, that is the scientific deliverables, which we want to understand is how to understand the buildability, basically metal parameters from micro and macro scale, to create a framework to predict the buildability and to get away from the trial and error method through print and to see where it fail. Rather to have a proper framework on testing methodology that we can do in lab, and to create a code of this, and uh, to make buildability as the primary factor for 3D printing. Since buildability connects the fresh states with the hardened states of the performance of the structure that is already printed. So one of the important things is to establish buildability as the most critical factor while designing the or while creating a 3D printed outline, or how to when we are planning to print something. Now, the engineering deliverables which we are going to do is to have a testing protocol considering metal parameters, to have quantifiable buildability parameters, and to see the effect of buildability parameters on mechanical performance or strength performance in the structural part. So the basic objective of the total study is again the same thing: to understand the fresh state, to have the metal parameters that are critical for buildability, to use different admixtures like accelerator, how to increase the buildability or to decrease the deviations that we can get while printing it. From microstructure, we can understand the rating the microstructural evolution with the metal parameters that are critical for buildability. To introduce sustainable binder systems that have a good property, like yield stress and other things that can actually help to have a stiff mix to hold or to help us to have a proper built structure. So like calcium sulfaluminate or limestone calcium clay cements to increase the aggregate binder ratio also, to have a higher strength, as well as to create a stable solution for that, and at the end to understand the failure mechanism. So how this criticality of the layers and criticality of the bonds is going to play the major role. So to come with the work progress, the first thing is that we have done is to develop a test method to design printable mix. I'm not showing it here, but we have developed a whole test protocol to design the printable mix, and if we follow it, we can get it. So we have moved from a not so well printable structures which are having deviations to much finer structures that we have printed over time, and we learn to assess the the metal parameters and to create proper mixes that can be printed in a better way. Now, to print well built up cubes by using different chemical admixtures, that is also critical, and to develop new method to enhance buildability post printing. So we have printed this toilet model, and we have used a novel method of spraying accelerator on the surface that we have used to increase the buildability of the structure, that it should not collapse. So suddenly if something is out of the way, we can use this technique to hold the system or to freeze the system at that moment, and then to rely on building further structures on it without creating a larger deviation or a failure. The next is to print a well-shaped cylindrical columns. We have optimized the mix. We have created much better columns of 1 meter, half a meter, 1 meter in a one go. To develop printable mix with low carbon cements like In-situ and CSA, it is under study and it is being in the lab now. Will be taken to the printing trials soon. So if you see further, then this is the 30-minute building that is there in IIT Madras that we have created using these different technologies, and this is how we have learned to use the accelerating admixtures from to create structures that cannot hold more than 4 to 5 layers to a structure that can go to 600 millimeter or 1 meter in one go, and also to add in a different ways how we have added the admixtures like chemical accelerators. We have found out different methods and quantified them and compared them with each other to find out what is the suitable method to do it, to add it at the nozzle, to add it at the mixture itself, or to spray it on the surface post printing to avoid any kind of collapse if there is any problem that has been occurred due to printing. Further, the work progress that is under continuation is to understand to define the mechanical testing procedure on the hardened state, to have hollow cylinders, to have walls, to understand how the cracks are propagating in this or through the horizontal joints, and joints are critical or the structure is critical, the vertical joints are critical, the horizontal joints are critical, the layer bonds is critical. To understand all those things is under progress at this moment, and to increase the sustainability of the printable mix using different binders that is already told you. The last thing that we are also trying to understand is the rheological and mechanical performance under different loading conditions, like binders, admixtures, and all these things. So this is a squeeze flow method that we are using to understand the behavior of the mix. So we go for a direct compression, stepwise compression, cyclic compression, and to understand how these accelerators and other things affect the metal behavior. So the furthest thing that we're doing is to understand the microstructural development, XRD and SEM, to see that how the formation of metringides, formation of CSH, and other things are critical for the macrostructural behavior, or the rheological behavior, and how we can tweak the macrostructure. The aim is to know how to tweak the microstructure for better macrostructural performance. This is the visible output. Thank you.
Thank you, Shantanu.
Yeah, hello.
Hello, Shantanu. Now the floor is open for questions. There are no questions from the YouTube. So if the attendees have any questions, please put it in the chat box, or you can unmute yourself and ask the questions.
Yeah, this is Mahalingam.
Yeah, hi.
What is the cost variation for the normal conventional building and the 3D building for normal G+1 building?
See, this is not a part of my study, and this is something that I cannot disclose out because we have another partner which from the industry. So,
okay. Thank you.
Thank you.
Thank you, Shantanu.
Thank you.
Just one second. I have a question for Shantanu.
Yes, sir.
Yeah. So, can you give your thoughts on how, at what stage the 3D printing technology is currently, and when you expect it to really be taken up as a mainstream technology?
So, I think 3D printing is in a phase where we understand the initial behaviors. We have done some good experimentation in the labs. We are doing the pilot projects, some experimental projects on the site, and it will take around at least 10 years to properly go into market as a good method of construction, because for architectural purpose and other purposes 3D printing can take over another 2 or 3 years. The only problem is that we have to have a solid understanding of the structural behavior and to control the geometrical intolerances and geometrical problems that we face while printing. Once that is done, it will take another 8 to 10 years to come to a full-scale construction in normal world. Right?
Thank you.
Yes, thank you.
Shantanu, this is Shivapurnan.
Yeah, hi.
Hi. It was a good presentation.
Thank you.
What I would like to ask about is regarding the there are some what you are working on is FDM process, right? Like deposition method, right?
Yeah.
So there is also seeming to be some powder bed methods and all. So what is your opinion on that? How good is it, or what are the advantages and or limitations about the powder bed method in 3D printing of concrete?
See, if you are talking about large scale structures, I think powder bed is not yet ready to create large structures like buildings where FDM method or extrusion based method is capable of doing it on site. But if you go for optimization of small blocks and to do topological optimization for brick elements and other elements that doesn't need like we are using a lot of materials for that, so we can topologically optimize that. For this, powder bed technology can be much more beneficial than extrusion based. So creating small block structures and all these things. But for larger, higher structural thing, or to go for a continuous wall printing, column printing, extrusion based is having an age at now, until if someone does a greater disruption with your powder bed technology.
Yeah, so this is about the size of the scale of the specimen you said, right? What about the strength aspect? Because in powder bed we are not able to compact it. So, or I don't have much idea, but as far as I understand, we are not able to mix it well, right? What we are able to do in a fusion. Is that right?
Yeah, true, but still we have other ways to go with it. Like we have high strength binders and special kind of binders that can take care of that. Okay. But strength purpose can be solved, but the scale purpose is a bigger challenge, I think.
Okay, thank you.
Thank you.
Okay, Shantanu, Gaurav here.
Yeah, hi.
Hi, I have a connecting question. What I've studied about this building technology, there is a thing called self-compacting concrete. So, how is there any role of that in 3D printing? And because it's also been studied quite a lot, so is there any way we can connect the two, or is your work in future it could be done in the way you are doing right now?
See, self-compacting concrete, the main idea of self-compacting concrete is that you don't have to vibrate it while you put it in a formwork. But for 3D printing, it's not only that you don't have to vibrate it, but it should stand on its own. So it should, when you extrude it, it should not flow out like a fluid. when it is getting printed. So there is a clear demarcation. But if you go for the pumping part, both have a kind of similarity where we have to create a mix that can flow properly. But still there is a like the application part or the part where it comes out of the nozzle where it has to be standing by its own for its own weight and take the strength of the further layers that are printed. There's a huge difference between both technologies, and they're independent. Might be the chemicals and other admixtures we use are same, but the mix proportioning to creating the admixtures are different.
Okay. Thanks.
Anthony, we have a question from YouTube.
Yeah.
I have posted in the chart.
Okay. When we compare the strength of 3D printed column and a normally casted column, what are the results we see? See, this is under study. So we are still printing. 3D printed column is mostly a hollow column where we try to pour it with further grouts and give reinforcement. This is a matter of study that is going on all over the world, and the more important question is to how to test the strength. It's not we cannot use the concepts of like full scale testing into this. Both have a difference. So I will say this is still under like when we understand that how to actually do the mechanical testings, will be in a better way to say that whether the normally casted columns are better or not better than the 3D printed columns. And for Anandarup also, hi. So study of long-term deformations for 3D printed load bearing is going to be part of the study. No, I'm not going a long-term deformation for 3D printed. Mine is basically for the early age and to see the binders and how the process of printing and 7 days or 28 days strength of the printed elements like hollow cylinders or walls are affected by the printing what we do. So the difference between the normally cast concrete and 3D printed concrete, and to understand how we can further create a representative volumetric element if possible to do these testings.
Yeah, continuing
Thanks,
on
Shantanu.
the last question, do you think that the creep would be a major issue in this, even though it's not your study? What is your opinion on it? Because we are not allowing much time for it to set before layers and other layers of print on it, right? So, do you think creep would have an effect of it? What's your guess?
Yeah, creep would certainly have an effect on this. Yeah, but I can't say that it will obviously have an effect on this, and a study should be done to understand the creep behavior. But again,
so you say that it would be more than what is there in the normally cast.
See, like I can't say that it will be more or less, but since at the same time it has places where the energy can dissipate. So it's a heterogeneous structure with places where it might not be a continuous load every time at the same point. So, but if you go for individual layers, it will be hardly affected. Yeah.
Okay. And one generic question that I have. So usually in other fields, the 3D printing is coming along, or even the 3D printing in construction industry came a bit later than the other fields of 3D printing, or almost at the same time. But what I think is that additive manufacturing was a bit new concept to the other fields, because in mechanical or other fields, they do mostly separative manufacturing, right? But we have been doing additive manufacturing for a long time. We always do additive, right? Except for stone carving or something like that. So why do you think we took so much time to get into this technology? What stopped us from doing this, or what is your opinion on this?
So one thing is that I think construction industry is a very conservative industry, because whatever we do, our mistake can cause not only money loss but life loss. So before taking any technology that is going to act like in additive manufacturing also, we are very much skeptical. Now, if we go for normal concrete system and normal construction processes, we have formworks and other things, and we are much more relied on later strength. So the material, to understand the material behavior on the earliest strength, whether it can take or not, to make the main printable ink that we have, I think that's where it took time. And it took time to see that whether like there is something missing in there. I think SCC has created a big picture there. Like, because the SCC became so much popular, we could move towards 3D printing now. So I will say that SCC is that missing link between the conventional construction technology and 3D printing. So once we are confident with SCC, we move towards the 3D printing. So that's where the difference came. So it's mostly the material which is critical rather than the technology itself.
What What do you mean by SCC? If you can elaborate, please.
Self-compacting concrete. So
Okay, SCC. Okay. Oh,
Yeah.
sorry. Yeah. Thank you.
we have two more questions. Like, what is the
Shantanu,
maximum? Yeah.
due to the time constraint, I
Okay.
request you to answer the questions either in the chat box or in the YouTube.
Okay.
We'll anyway address all the questions. Okay.
Thank
So we can move to the next speaker. Thank you, Shantanu. Next speaker is Nandan.
I am Nandan Maiti, a direct PhD scholar under the guidance of Dr. Bhargav Ramachilipuri in the Department of Civil Engineering, Transportation Engineering Division. The topic of my today's presentation is macroscopic model for heterogeneous traffic conditions. This is the outline for today's presentation. Growth in traffic leads to congestions across the several cities, which results in access delays, reduced safety, and the environmental issues. The traffic in India is heterogeneous in terms of the vehicle, road, and the driving characteristics. But the existing model all are developed for homogeneous and plane-based model. As you can see in figure 1, the left side image shows that this is a homogeneous and lane-based traffic, whereas our Indian traffic is the right side image. It shows that there is no lane-based systems and the traffic is fully heterogeneous in nature. So over the year, the researchers has developed multi-class model and non-lane based model to accommodate the vehicle class heterogeneity. The macroscopic model consists of two main concepts. One is the fundamental diagram, another is the state propagation equation. Fundamental diagram is the steady state relationship between the traffic flow variables, that are the speed, density, and the flow. There are many fundamental diagrams developed over the year for homogeneous traffic flow. Among them, Dragon-Jones, Greensill, and Drake are the well accepted fundamental diagram. Based on the assumptions of the relations between the traffic flow variable, the shape of the fundamental diagram changes. You can see the Dragon is triangular, whether the green seal is the parabolic and the Drake is the exponential for the speed versus density relationship. The state variable, the traffic flow variable measures for this fundamental diagram are lane based. Log-EMAS proposed a steady state relationship between the state of different vehicle class, that is called the multi-class model. So this is the heterogeneous vehicle class fundamental diagram. But for the both cases, we need a area and directional definition traffic flow variables. Cause both cases the fundamental diagram was developed for lane-based traffic. The state propagation equation, that is the traffic flow models. Lightfield, Whitham, and Richards first proposed the kinematic wave model in 1955. The kinematic wave model consists of the continuum equations and the fundamental diagram. The solution of the kinematic wave model gives how the traffic state propagate in the time-space domain. The first order model, that is the kinematic wave model, able to predict the state propagation, wave formation, and the traffic dynamics at the stationary and the moving bottleneck, but can't able to explain the capacity drop, hysteresis, relaxation, and photon diffusions traffic phenomena. So over the year, higher order model developed to explain the capacity drop, hysteresis, and the relaxation in the Platon diffusion, that are the drawbacks of the first order kinematic wave model. This model considers only the one direction, that is the x direction, for the traffic state propagations. Lateral movement do not considered in this model. The model not consider the lateral movement and non-lane based movement. So we need a robust model for the mixed traffic conditions. Based on the thorough literature review, I come up with a set of research gap for fundamental diagram and traffic flow models. The research gap for fundamental diagram developed for particular class of vehicle. Intervehicular interactions were not considered in the fundamental diagram. Traditionally, passenger car equivalent based fundamental diagram were developed to accommodate the vehicle class heterogeneity. But we need a composition based fundamental diagram to understand the intervehicle interactions. In the research gap for traffic flow models are developed based on the lane based traffic. They are not developed for area and directional defined traffic flow to understand the non-lane based movement. Traditionally, traffic flow models are one dimensional, that is the x and t was there. So we need another dimension to understand the non-lane based movement. Gap, I proposed the problem definition and objectives of my research. The problem definition of my research is incorporating vehicle heterogeneity and the lateral interactions into the macroscopic model to make them suitable for representing mixed traffic conditions. And the objectives based on this problem definitions are empirical investigation to incorporate lateral interactions in the fundamental diagram for non-lane based heterogeneous traffic conditions. The objective 2 is develop a two-dimensional traffic flow model to replicate traffic flow phenomena of different vehicle classes in a non-lane based system, and then developed a suitable first order numerical solution for the two-dimensional kinematic orbit model and then validate the proposed model with empirical data. Basically, the existing macroscopic model is homogeneous and lane-based movement. We need to incorporate the vehicle class heterogeneity and non-lane based movement. So we need a revised definition of the fundamental diagram and the traffic flow variable to represent the non-lane based traffic flow. Now I will discuss the methodology of my research. The first step is the data collection of macroscopic traffic data, the trajectories of the mixed traffic. Then the analysis of the macroscopic data to estimate the traffic state and the vehicle class interactions. The composite specifics fundamental diagram estimation to incorporate the lateral interactions. In the traffic flow model development for non-lane based movement where the anisotropic conditions will be satisfied and area occupancy conservation equation will be incorporated into the conservation equations. And the last is the development of a first order numerical solution to solve the traffic flow model. Objective and methodologies. I collected 1.54 video data of two-lane 2-way traffic in Sardar Patel Road, Chennai during an evening peak hour. The trajectories were extracted by machine learning and deep learning algorithm. Here figure 7 shows the trajectories of different class with their instant speed. Then I analyzed the data over a 20-meter detector. First I calculated the class specific speed, that are the VIJK. Then VJK is the stream speed, which is the density proportion of the class specific speed. Then the stream flow and the stream density. From there I calculate the area occupancies. So I proposed a methodology to estimate the composition specific fundamental diagram based on the Gaussian mixture model, where the model takes input vehicle proportion of two-wheeler, car, heavy vehicle and auto. But the traffic proportion based Gaussian mixture model clustering leads to a weak classification of congested regime data. Then I proposed state optimization technique for the congestion regime data over the Gaussian mixture model. Upon converging of state optimization technique, we observed different wave speed for different traffic compositions. So the fundamental diagram that we proposed have only one linear relationship between the flow and density in the free flow region for different traffic composition, whereas different wave speed for different traffic composition in the congested regime. Showing the relationships of stream speed versus area occupancy for different composition of the stream. As you can see that for two different composition A1 and A2, stream speed is a non-increasing and non-linearly related with the area occupancy, where the magnitude of the speed for a different composition is different for a particular area occupancy value. Of my work, I have developed a composition specific fundamental diagram using Gaussian mixture model and the state optimization technique. As we have already seen, the single linear relationship between the traffic flow and density in the free flow region for different traffic composition, we can conclude the mean speed for different composition class is equal. And in congestion, the wave speed are different for different compositions. So wave speed for a higher proportion of heavy vehicle is higher. So if C2 has the higher proportion of heavy vehicle than C1, then we can prove that delta Q by delta K, that is the wave speed for C2 composition, is greater than the wave speed for C1 composition. Then the stream speed will never be zero due to the percolating behavior of the two-wheeler. So if the stream has two-wheeler proportion, then the stream speed will never be the zero. Then the higher proportion of high-speed vehicle like two-wheeler car with a higher capacity. From the remaining objective, the proposed future works are the development of a traffic flow model for non-lane-based heterogeneous traffic condition, where we'll incorporate the x as well as the y direction in the continuum equation. Then we'll develop a first-order numerical scheme. Then we'll validate the model with the empirical data. Published and under review visible output of my research. Thank you. I am Nandan Maithur.
Thank you, Nandan.
Hi, good evening. Thank you.
Now the floor is open for the queries.
Hi Nandan, this is Shivapurnan.
Hi, tell me, so
Yeah, it was a good presentation.
thanks.
So what I wanted to ask was, usually for modeling this traffic, some of the literature also, as far as I know, they consider a fluid particle based models to approximate the model of traffic flow, right? What is your opinion on this? Can it be done for only homogeneous kind of traffic, or even for the heterogeneous, like what you're considering?
Okay, so basically, the continuum equation, what I showed you here, this is comes from the fluid flow analogy. But the we can't take the fluid flow analogy as a whole for the traffic, because we know the fluid is an isotropy, but in case of traffic, it's anisotropy. And there are so many things that they are fluid density. We call this fluid density, but in case of traffic, we can't call it density, because traffic is not isotropically it's distributed over the road. So there are many assumptions is there, but yes, we model the traffic flow as per fluid flow analogy, even in the gas flow dynamics. But for modeling the traffic in heterogeneous conditions, we need to consider many things like traffic compositions and yeah, the size of the traffic, their maximum speed. So all of these things we have to consider for traffic. But main analogy can come from the fluid and gas.
Okay, is the behavior dependent on the scale? Like even in the larger scale, can't we say that we have almost isotropic or homogeneous behavior?
The large scale
Means if I see the lane or the lane or the length of the road is very high, then I have so much of vehicles, right? In that case, also can't I approximate it to be homogeneous?
No, actually, if we consider a long length and length is long and width is long, then also we can't consider it as a homogeneous, because the vehicle size is here different and vehicle dynamics and kinematics is different. So it's not move in a flow. It will move in different kind of flow for different class of vehicle. So the each and individual class will behave differently. So we can't take it as a homogeneous. We have to model it in heterogeneous for our Indian traffic.
Okay. Okay. Thank you.
Thank you.
I request the speakers, whenever they're answering the queries, to keep their videos on.
So we got one question in YouTube. Do the lane-based model perform better than non-lane-based method? And why do we still follow non-lane-based traffic in India? Do the lane-based model perform better than non-lane? So obviously for Indian traffic, so we can see that the two-wheeler and the small vehicles, they don't follow the lane discipline. But whenever they find some gap, they try to percolate in between this gap. So what happened if we consider this traffic as a lane waste? We won't be able to predict. We won't be able to mimic the whole scenario that's happened in this side actually. So eventually we'll be ending with a estimation that is not Indian conditions. So we need a non-lane based movement, because in Indian traffic they don't follow the lane based system. I mean, they will in congestions they will obviously shift the lane one to another. So there is many things will come, lane changing model will come. So if we consider all these things together, then only we can able to predict the propagations of these densities and speed, whatever the traffic state with time is correctly. Otherwise, we won't be able to predict the traffic state correctly. I hope it answered the others' question.
Any more questions for Nandan?
Hello. I have answered the question for others. Any question for me still?
So there are no questions from YouTube. So the attendees, if you have any queries to Nandan, please post it in the chat box or unmute yourself.
I got one question from YouTube. Others actually asked one question. I answered this question.
Yes, yeah. Thank you. So if there are no more questions, thank you, Nandan.
Thank you.
Next speaker is Kirtana from Geotechnical Engineering Division.
Hi everyone, I am Kirtana. I am a research scholar in the Geotechnical Division of Department of Civil Engineering, IIT Madras. My research topic is development, characterization and hydraulic performance evaluation of in-situ polymerized bentonite for barrier applications. Coming to introduction of the study, geosynthetic clay liners are widely used as hydraulic barriers in many geoenvironmental applications such as dams, canals, heap leach pads, engineered landfills, storage ponds, cutoff walls, etc. GCL is a composite consisting of clay and a geosynthetic material. It consists of a thin layer of bentonite sandwiched between two geotextiles called cover and carrier geotextile. It is relatively impermeable owing to the high swelling capacity and low hydraulic conductivity. But the prolonged exposure of clay to solutions containing high concentration and balance can increase their permeability with a consequent damage to the environment. This problem is addressed in the present study by modifying the sodium bentonite present in GCL with a superabsorbent polymer by adopting the latest in-situ polymerization technique. Various studies have assessed the attributes for a liner material such as hydraulic behavior, self-healing capacity, sorption ability, and diffusion characteristics. Polymer intercalation and pore clogging is reported as the mechanism for their enhanced properties from the microstructural perspective. The above studies showed that the polymerized bentonite has superior hydraulic performance compared to the untreated ones. Recently, the studies have focused their attention on developing new chemical formulations for these polymerized bentonite. As they are at the nascent stage of research, there is a limited data concerning the hydraulic behavior and their long-term durability. Based on this, the objectives of the present study are defined as to develop an in-situ polymerized bentonite based on optimum chemical polymer mix using design of experiments and to evaluate their swelling capacity under various chemical environments. The materials chosen for carrying out the present study are sodium bentonite and the polymer used was polyacrylate. To achieve the above objective, the following methodology was adopted. The polymer was synthesized using the setup shown in this image. It is prepared by using a monomer solution of acrylic acid and NaOH. It is followed by the addition of crosslinker and initiator. Polyacrylate has the capacity to absorb large amount of water molecules. So to know which proportion of this chemical mix gives the polymer a maximum water absorption capacity, an optimization experiment was carried out using response surface methodology. The factors considered are initiator, crosslinker, and the neutralizing agent, that is NaOH. Its corresponding low and high levels are shown in this table. The factor studied is the water absorption capacity of the polymer and is calculated using the formula given here. Minitab software was used to obtain the design matrix as tabulated here. For all these 17 runs, the polymer was synthesized and its water absorption capacity was measured. The same procedure for polymer synthesis was used, except the bentonite was added to prepare the in-situ polymerized bentonite. At end, the final product was oven-dried and was ground to match the required particle size distribution. For testing, a bentonite polymer composite with 30% polymer content was prepared and its well index was measured under various chemical environment. Let us discuss the results of optimization experiment. A mathematical model was developed as shown here for predicting the water absorption capacity of the polymer. It was found significant as witnessed from the values of the statistical parameters as shown here. This figure shows the predicted and the measured water absorption capacity values of the polymer. Here it can be seen that the points are distributed close to the straight line, which confirms the significance of the predicted model. Optimizer tool from Minitab software was used to determine the optimum proportion of the polymer that gives the maximum water absorption capacity. The results of optimization matched well with the values reported in the literature. At optimum, the model predicted a water absorption capacity of 306.9 gram per gram. To verify this value, the experiment was performed at the optimum and the water absorption capacity of the synthesized polymer was measured to be 305.1 gram per gram. This negligible difference supports the validation of the predicted model once again. This slide shows the variation of water absorption capacity with the studied factors that are initiator, crosslinker, and NaOH in contour and surface plots. It can be seen that there exists an optimum on these surface plots on either sides of the levels that are considered for the study. These are the results of the swell index test performed on the polymerized bentonite. It's observed that the swell index in water after polymer treatment has been increased to twice the value of the untreated bentonite. The swell index was found high in sodium chloride, followed by calcium chloride and then aluminum chloride solution. This phenomenon illustrates the effect of cation valence on the swell index of bentonite. This graph shows the variation of swell index with the concentration of different test solutions. As the concentration increased, the swell index dropped rapidly, and at higher concentrations, nearly the same swell values were obtained. It can be inferred that with the increase in concentration and valence of the test solution, the swell index of the polymerized bentonite was decreased. The following are the conclusions drawn from the present study. Central composite design was used for polymer optimization, and the optimum contents were obtained at 0.32, 0.15, and 16 weight percentages of initiator, crosslinker, and NaOH respectively. A mathematical model was developed for predicting the water absorption capacity of polymer, and its adequacy was verified using the goodness of fit and lack of fit test. The effect of factors such as initiator, crosslinker, and NaOH was studied using the surface and contour plots, and it was found that the polymer's molecular weight, polymerization rate, the cross-linking density, and the NaOH weight percentage has affected the water absorption capacity of the polymer. The results of swell index test was found consistent with the findings of the diffuse double layer theory. Overall, when compared to the untreated bentonite, the polymerized bentonite has shown superior swelling property, and hence it can be used as an alternative for the liner material. Thank you.
Thank you, Kirtana. Now the floor is open for queries. Kirtana, are you in the meeting?
Yes, Anupama.
There are no questions from the YouTube. So if the attendees have any queries, please feel free to ask Kirtana now.
Hello, Kirtana. This is Shiv Purman.
Yes, sir.
Yeah, so what I wanted to ask was overall what I understood from the study is that polymerized bentonite was showing a better performance than the Untreated one. Yes.
one.
Yeah.
Yes,
So
sir.
is this was this not what was that is done in the literature, and what was additional thing that you were able to do? Like they were not able to do the polymerized bentonite and show its performance. Was it something like that?
No,
Or
sir.
were there some problems that you could overcome?
Yes, sir. Till now, the studies they have used polymer to modify the virgin sodium bentonite, but this method is a novel one where we won't add the polymer directly to the bentonite. Instead, the monomer will be added first to the bentonite, and then in presence of bentonite, this monomer will be allowed to polymerize and it will be converted to polymer. So the polymerization process is happening within the bentonite itself. So this process of modifying bentonite will improve the clay polymer interaction, and it helps to increase its hydraulic and chemical resistance in aggressive conditions.
Okay, so this was compared with the ones that were done in the literature, and you were able to show that those things it was able to bet your
Yeah, its performance was better, sir.
found to be better. Okay.
Yeah,
Okay.
in terms of swelling.
Okay.
Yeah.
And the results are not shown here.
Sir?
Those results are not shown here, right? Or I think I missed it.
No, sir. Swelling results was shown.
Okay.
Yeah.
Okay. Thank you.
Thank you.
Yeah. Hi, Kirtana.
Hi.
Yeah, nice presentation. I just have a small question.
Yeah.
You told the mathematical model was developed for the water absorption.
Yes,
like
yes.
How efficient it is? Like how many parameters you might require? Like how efficient model?
Okay, so this we used Minitab software for doing the design of experiments. So in that, we used multiple regression analysis to develop this model, and the parameters in that software we could able to get a second order equation where we have tested for its significance using ANOVA, and then based on the significance of the term, the insignificant terms were neglected, and the model that I have shown in the presentation, it includes only the significant terms. With significant terms, the model was developed. It contains only the significant terms.
Okay. Yeah. Okay. Thank you.
Yeah.
One more question that I have. This is Shivapunan again.
Yes, yes.
Yeah. So actually, in the previous question, you had said that you had added a monomer and that got converted into polymer, and because of that, you had certain advantages, right?
Yes, sir.
So, what was the motive behind, or how did you come up with this idea? What led you to this concept to do that, so that you were able to get that advantage?
No,
were you able to foresee the results that you might get, or was it based on some trial?
No, sir. This method, this method has been used in the literature, but I have improved it by modifying the chemical proportion of the polymer that is being used. So this polymer, the constituents that we use for preparing this polymer, it has a lot of significance on the end results of the composite material that we are going to make. So this composition, I have come up with a new composition by including cross-linker, and I have modified the polymer itself, like the proportions and all. I have adjusted.
Okay, so how did you adjust that is my question. So how did you foresee it? How did you know that a certain adjustment would lead to your betterment of the results?
Yes, for that only to know, in my study, I have 3 constituents for making the polymer. One is monomer, another one is initiator, and another one is cross-linker. So to know which proportion of this polymer will give me the maximum water absorption capacity, I don't know which combination. So in order to come up with that combination, I have used design of experiments, where it is a statistical procedure by which we can able to arrive the optimum content with less number of experiments and as well as the use of resource.
Okay.
It saves our time. Yeah, it's basically a statistical procedure.
Okay.
Yeah.
Okay, thank you.
Any more query for Kirtana? Nothing from YouTube also. So thank you, Kirtana. We'll
Thank you,
move to the
Nupama.
next speaker. It's Varun Reja from Building Technology and Construction Management Division.
Hello everyone, welcome to my PMRF talk. This is Varun Kumar Reja from IIT Madras. I am a joint doctoral degree candidate from IIT Madras and University of Technology, Sydney. I am being guided by Professor Koshi Varghese at IIT Madras and Professor Kwang Ha at UTS. My topic of research is on computer vision based progress monitoring of construction projects. Construction project management is a 3-step cycle with key components as planning, monitoring, and control. Monitoring is a critical phase, and to monitor, we require to compare the as-built progress with the as-planned progress. Hence, it requires an as-built model generation. It is a challenging task. If the cycle gets compromised, the project runs into time overrun and cost overrun. The main motivation behind this is that progress monitoring is used in many things like machines, planning for machines, cash flows, manpowers, and delays. Conventional progress monitoring, which is generally a pen and paper based method, is labor intensive, time consuming, prone to errors, ineffective, and therefore non systematic and too infrequent to enable prompt action. The newer technologies like laser scanning, photogrammetry, videogrammetry, and range imaging have been the newer version of technology used for progress monitoring. These have the use of these has been increasing because the use of cameras and laser scanners have been increasing worldwide, the decrease in cost, and the improved processing capabilities. I start with the literature review where I systematically classified the existing studies on progress monitoring based on what technology they have used, whether they have integrated BIM model in it or not, and what stage they have done the progress monitoring in the last column. And also I explored in these studies how many elements have been identified in a building. So as you can see, there are structural elements that have been identified, MEP components and blockworks, etc. So from literature review, there is a conclusion that there is no comprehensive framework, there is no benchmarking study and test bed, and sparsely explored deep learning based techniques. So the progress monitoring framework is a 3-step process which I get from the literature. First is the data acquisition and 3D reconstruction, which can be done through multiple techniques. Similarly, as-built modeling, the second step, where many types of as-built models can be built and can be used for progress monitoring. And finally, progress estimation, where various phases of progress can be shown based on either overlapping or quantity estimation from the existing methods. So this is the entire process. As you can see, this process is quite complicated because in the first step there are various acquisition technologies and methods and algorithms. Second process, as I told, there are multiple type of models. In progress estimation and quantity estimation, there are various methods, and finally pipelines have detected various kinds of elements, etc. In addition to this, conventional scan to BIM is actually used currently at construction projects. In conventional scan to BIM, a point cloud model is scanned and manually the walls, the windows, the floors are built in the computer. So the challenges are, it is a time consuming process. it is less accurate, it is manually very intensive, it requires tool sets and therefore domain knowledge also to use them. Also, there are various kinds of technologies available in the market for progress monitoring, which varies on cost, mobility, training requirements, etc. To benchmark these technologies, we don't have anything. So hence, this is one of the gaps. So I present one on right hand side the gaps here, that the actual implementation data has to be seen for progress monitoring techniques. A systematic evaluation is missing. Scan to BIM is still an evolving problem, and smooth and automated workflow needs to be made. Learning based techniques have been very sparsely explored. There is no empirical data on benchmarking or test beds on these pipelines, and there is big gap between research and implementation. Hence, the objective of my research are to evaluate existing solutions for progress monitoring using actual site data and challenges faced to adopt the advanced techniques, to assemble an integrated framework for vision-based progress monitoring in construction, to develop pipeline for automated capture of elements using heuristics and learning-based methods, and finally to design an experimentation testbed for automated progress monitoring. This is the methodology or the roadmap I will be using. In the red marks the key milestones of my project. So I have completed the objective 1, 2 and partially objective 3, and now I will be showing the results about objective 3, which is the element identification. So we used a heuristics based approach, a constraints based approach for this objective, and as you can see, the heuristics there are sub objectives to this objective. That first we have to identify a heuristic which can give the progress easily and to experiment it, and the scope is on building structures. So the concept behind this is, we have in the blue you can see an as-built point cloud which is directly taken from the site. This is acquired through scan. What concept we are using here is that we will compare the number of points per element on this point cloud with the number of points with the as designed BIM. This will be extracted from the as planned model of the building, which is a BIM model, and we will create the points of equal intensity. So dividing the number of points per elements, we will get the progress about each element. You can see the overlap visualization here. So this was done using Grasshopper 3D scripting, and so this is one more model. This is the real this is a synthetically generated model of as built BIM model which will be generated, and this is the as designed model, and we compare the number of points based on equal intensity. Point intensity we define as the number of points per unit surface area. So we compare the number of points in each element and we get the progress. So this work has been accepted at International Symposium for Automation and Robotics in Construction in Dubai, and these are the preliminary results, and this report you get in one click. So the expected contributions of this research are, first of all, to generate a process framework for computer vision based construction progress monitoring, to use heuristics based approach, which I have already done, and learning based approach in conjunction to see what is the result, and with that we will be also producing our benchmarks dataset and test bed. And secondly, an easily implementable in practice, an easily implementable approach for construction industry which they can implement on site, and guidelines to adopt computer vision based progress monitoring on construction sites. Hence, this is my research timeline. I have completed my research proposal seminar and candidature assessment 1 and 2 at UTS, University of Technology Sydney, and IIT Madras respectively, and now I am planning to work towards my remaining objective 3 and objective 4. I have spent 1 year of my research virtually doing joint doctoral with Professor Kwang Ha, and I will be continuing to do so in an online mode, and I plan to submit my thesis in mid-June next year sometime. These are the visible outputs. The first 3 papers has been accepted, the other are published, and the last one is the book chapter which is published. So thank you.
Thank you, Varun.
Yeah, hi Anupama.
Hi, Varun. So, now the floor is open for the questions. There are no queries from YouTube. So the attendees, if you have any questions, please feel free to share with Varun. If there are no queries, we'll move to the next speaker. Thank you, Varun.
Anupama, there is just right now a question in YouTube. Is the vision-based monitoring relatable for all types of construction projects? Thank you, Selvam, for asking that question. Yeah. So yes, it is relatable to. Okay, you mean reliable? Okay. So yeah. So there are different techniques to monitor different kinds of projects. For building projects, you have a 3D. You require a 3D visual model of monitoring a projects. You can also do it using images. But for example, for linear construction projects like road projects and railway projects, there is no much of 3D element involved. Hence, you have more kinds of photogrammetry based approaches, which uses drone based surveying for detecting the progress based on types of images captured or the point types of image data captured. So yeah, these are very reliable. They have been and predominantly used in construction for the past 5 to 6 years, the image based methods, and they give pretty good accuracy. But the 3D reconstruction methods, which I am exploring right now, they have not been the reliability have not been actually taken place because they have not been used much in construction because of the data, the size of the data and the computational power required to process it. So hence I am working towards a heuristics based methods and a learning based approach and a combination of two approach, so that computation will be pretty smooth, or people can do it on site level itself. Thank you.
Any other questions for Varun? Okay. Varun, I request you to please answer if any more question comes in the YouTube there itself.
Sure. Thank you.
As of now, nothing is there. Yeah, thank you. So we'll move to the next speaker. It's Meenakshi.
Hello everyone, my name is Meenakshi. I'm a PhD scholar in Structural Engineering Department working under the guidance of Professor S.T.G. Raghukant and Principal Scientist Senthil Kumar. In this symposium, I would like to present the following contents. Initially, a brief introduction, the proposed research objectives, and a summary on literature review, methodology, work done, a further scope or work of every objective, and a tentative work plan for further research work along with the visible output. Till 2018, Moon is the only body in our solar system other than Earth where moonquakes are instrumentally recorded by a network of Apollo seismometers for an operating period of 8 years. In those 8 years, 28 shallow moonquakes were recorded and they resemble the characteristics of intraplate earthquakes. Apart from those characteristics, they also exhibit a very long duration and a gradual decrease in amplitude along with the prolonged coda. So from the figure we can see that we can observe only the P and S waves, but we cannot able to identify the secondary seismic waves and the surface waves. So because of this, only one-dimensional velocity models are available for the moon in the literature. Due to the complex characteristics of the moonquakes and the lack of sufficient seismic data, the process of seismic wave propagation inside the moon is not well understood. So, in order to deepen our knowledge on the lunar interior, numerical modeling of seismic wave propagation inside the moon is considered as the most realistic alternative. As far as engineering interest, the possible ground motion due to the moonquakes can be estimated by modeling the moon using such numerical techniques. This in turn will helpful in estimating or suggesting the possible landing site for future deployments on the moon. So we know that the moonquakes were recorded in the past 1960s. Whether still the moon is tectonically active or not is not known. So recently, with the deployment of the LROC mission, near surface features like scarps, landslides, and a boulder falls along with the boulder trail marks were identified with the help of the high resolution images. So we know that since the seismic activity is highly correlated with these such type of the faults and surface features, it is believed that the moon is tectonically active. So, after understanding the drawbacks in the available numerical models for the moon as well as the research gaps in the literature, the following objectives were framed. The first objective is to develop a spectral element model in order to study the global seismic wave propagation in the moon. In this, the global model will be developed and the developed model will be compared with the normal mode techniques as well as with the Apollo data in order to validate the model. And finally, peak ground velocity contours and the peak ground residual contours were generated over a region in order to determine the possible ground motions for a shallow moonquake. So after this study, in order to overcome the limitations in the developed spectral element model, a second objective is framed. In this objective, hybrid broadband ground motion simulations are simulated for the moon. In this, low frequency and high frequency ground motions are simulated. In addition to that, in order to generate the high frequency ground motions, a parametric study on the scattering properties of the moon will be performed. So once the broadband ground motions are generated as an inverse problem with those simulations at various epicentral distances, how much PGA is required to topple or overturn a boulder will be estimated as an application to this objective. Further, once PGA and PGV are estimated for the moon, seismic hazard map for the moon will be prepared. For that, initially, all the seismically active tectonic features will be mapped to prepare a seismotectonic map for the moon. And finally, the possible magnitude that can occur from the faults using the Gutenberg relation will be estimated. And from that, the probability of exceedance of spectral acceleration due to all possible moonquakes will be determined using the probabilistic seismic hazard analysis. With this, a preliminary information about the ground motion on the moon will be completed. So by following the similar methodology of spectral element method, for the fourth objective, Venus will also be modeled and the seismic wave propagation in various planetary bodies will be compared and studied. In the following slides, I am going to present a brief methodology and work done for every objective. While coming to the first objective, initially in the literature, already spectral element models are developed for the Earth and the Mars to study the seismic wave propagation. So in this study, a similar methodology is adopted to develop the globe model for the moon, and it is completely based on the spectral element method, which is derived from the weak formulation of the wave equation, which is a very geometrically flexible and computationally cheap technique compared to the finite difference method and the pseudospectral methods. So the main or the first step in developing a globe model is meshing. So in meshing, the following parameters are incorporated: the internal structure, which is obtained from the modified Vipramun model in the literature, and the ellipticity is incorporated by modifying the flattening coefficient, and it is observed in the earth and the Mars that long period seismic waves are influenced by the rotational gravity, so both are incorporated. And in order to study about the role of topography or influence of topography on the ground motion, a 4-degree resolution of topography obtained from the LROC WAC mission is incorporated in the present model. Once all parameters are incorporated into the globe, the entire globe is partitioned into 6 chunks using the cubed sphere mapping technique. So, in each chunk, the radius and the number of layers in each subregion are changed according to the internal discontinuities in the velocity models. So it is observed that generally the P and S wave velocities increases with the depth. So the size of the mesh or the size of the element are designed according to that. But in order to maintain a uniform grid resolution throughout the depth, a stage doubling technique is performed. So from this, the each chunk is discretized into 160 spectral elements on either side along x and y direction, which leads to a element size of 17 kilometer on the surface, and the distance between the two nodes in an element is a 4.5 kilometer. And in order to maintain numerical stability, the time step used for the model is 0.095 seconds. So once the measure runs successfully, the double couple source is provided as a source mechanism in the form of a CMT solution in order to generate the synthetic seismograms for the moon. In the next step, the model is validated with the Apollo data. Further, the Apollo data is obtained from the DARTS website where the passive seismic experiment data is stored. And for validation, an event occurred on the March 13, 1973 of magnitude 3.2 is considered. And for validation, two different crustal models were considered. In the first crustal model, a low velocity layer of shear wave velocity 0.5 km per second is considered, whereas for the second model, an average crustal velocity model is provided. From the results, it is observed that the low velocity layer model makes it difficult to identify the various seismic phases, whereas in the average crustal model, it is easy to identify most of the seismic phases, and also it shows the similar decay pattern corresponding to the Apollo data. And in addition to the synthetic seismograms, the envelope of the synthetic seismograms and the recorded data are also compared, and the model 2 shows the better comparisons with the recorded data compared to the model 1. From previous results, it is also observed that even without the presence of the low velocity layer, long reverberating trains are observed. So what is the reason behind that long reverberating trains? Is it due to the topography or low velocity layer is studied? For this, the influence of topography on synthetic seismograms are performed, and for this a 4.1 magnitude event of a 5 kilometer focal depth is considered. And from the results, it is observed that the coda waves are observed even without the topography, but due to the presence of topography, a long reverberating trains were observed at all stations. From this, it is observed that the topography act as a constructive interference in forming the multiple reflections from the subsurface layers. As an application to the spectral element model, peak ground velocity contours and the peak ground residual displacement contours were generated for the south pole of the moon for a possible shallow moonquake to understand the influence of the ground motion over a region. With this, the likely deliverables under the objective 1 is completed, except the validation with the normal mode techniques, and the work is currently under progress. So, while coming to the second objective, as a developed spectral element model, can generate only the low frequency synthetic seismograms and cannot capture the near field effects as the model have an element size of 17 kilometers on the surface. So in such cases, there is an increasing need to rely on the simulated ground motions in the near source regions. But it is also reported in the literature that the scattering in the moon increases with the increase in the frequency content. So the scattering in the moon is nothing but it's a layer formed due to the irregular distribution of the crater craters and ejector blocks when the upper crust is fractured. So in the following figures, you can see that when an incident wave is obstructed by any obstacle or any scattering object, the energy or the seismic energy is reflected in various possible directions, which is nothing but the scattering phenomenon. In order to generate the broadband ground motions, the scattering Green's functions are convolved with the source time functions, whereas in order to take care of the high frequency near field effects, CutPy is incorporated, and both together will provide the high frequency ground motions. Whereas the low frequency seismograms are obtained using the spectral element method, in which the attenuation and the medium heterogeneities are adequately modeled. So both the low frequency and the high frequency ground motions are combined together in the frequency domain using an optimization technique at every receiver location to get the broadband ground motion. So in this objective, as a first step, the low frequency synthetics were modeled for the Oriental Basin by incorporating all the material heterogeneities as well as the topography. Simulations were performed at various epicentral distances, as well as the peak ground velocity contours were mapped over the topography by keeping the stations at every 1 kilometer by 1 kilometer grid. So for those stations, high frequency synthetic seismograms has to be generated, but further scattering parameters are required for the moon. Due to the lack of scattering parameters for the moon, a similar tectonic region is modeled, and those parameters are used for the moon. For this parametric study, Koyna region in peninsular India is considered for modeling, and a preliminary study is completed by modeling the Koyna region for December 10th Koyna earthquake by incorporating a one-dimensional velocity model. The sensitivity study of the scattering parameters is done by matching the recorded data with the simulations, and finally arrived at the optimum values of scattering parameters. But with the recent availability of the 3D velocity models for Koyna region, whether there will be any change in the scattering parameters or has to be determined, and this work is currently under the progress. A preliminary work is performed for the third objective by mapping all the seismically active features like the young lobate thrust faults and winkle ridges and the lobate scarps. Here in this picture, these lobate thrust faults were digitized from the Waters et al. Using the Gravit tool, whereas the wrinkle ridges and the lobate scars were obtained from the LROC website. Similarly, for the fourth objective, input parameters like internal structure and topography for the development of Venus models is also completed, and this is the proposed timeline for the further research work, and this is the visible output, and these are some of the references that are used in the current study. Thank you.
Thank you, Meenakshi. Now the floor is open for question and answers. There are no questions from YouTube. So the attendees, if you have any queries, please ask Meenakshi.
Hi, Meenakshi. Anil here.
Yeah, bro, tell me.
Yeah, I just want to know, you did the meshing, right?
Yes.
So, like, how did you decide on the mesh size? How the mesh convergence? Like, is there a mesh convergence, or like how did you decide the mesh size?
Actually, the mesh has been plotted, but like minimum resident period we have solved. Like while solving the while meshing itself, there will be like a CFL criterion we have selected. While how well the wave field is sampled by using the grid points per wavelength, everything has been checked according to that, and based on that only the everything has been determined, like how much current stability number has to be provided, how much the time step has to be provided, everything, like it's like a guess. Initially with the guess it started, and then by changing the mesh with n number of times, like with varying the parameters, we came to the concluded like this will be the suitable parameters which can sample the wave field correctly.
Yeah, okay, thank you.
Yeah, thank you.
Hello, Meenakshi, this is Shivapurnan. It was a good presentation, although most of it were too complex for me to understand. Now, the question that I have are more generic. So, you had said that the moon is the only body other than Earth, which is tectonically active, right? And why are the other planets not active? Is there a particular reason for it? Like, as you know,
Still we don't know whether it is active or not, because there are no seismometers are present on those planets to know like whether they are tectonically active or not. Still the now even till 2018 I told like moon is active, but now with the help of this InSight NASA mission, we came to know that Mars is also active, and there are so many Mars quakes are happening, and those data is also available. So both moon and Mars is also active now.
okay. So is it not possible to get an guess of this tectonically active thing by photos and seeing those things? Because somewhere you said that seeing the faults and fault, you would be able to say whether it is tectonically active or not, right?
Yeah, we can able to say, but we don't know that how much magnitude of earthquake or how much ground motion has happened to form such type of features. We can't able to tell just by seeing those imageries.
Okay.
We can say just by seeing those features like, okay, there's some type of seismic activity or some type of mass wasting process has been happened, so such features have been occurred on the surface.
Okay. And one more question I had was, what is the motivation for carrying out the study on moon? So, because we have a lot of things in Earth as well, right? So, what do you think would be the motivation to study the moonquakes and
While going through like how to model a heterogeneity or homogeneous medium in a three-dimensional body, while studying those literatures and all, we came to know like, okay, one only for moon there are no models are available to predict how much ground motion can occur. And with the like news of like there are some going to new missions will be there for moon or else for Mars, like some landing missions will be there. So why can't we predict like some suitable prediction for them, like where they can land safely, like that? Came.
Is there a region of interest, or you're considering the whole satellite?
No, right now, based on that, like only for few particular regions were selected to study it. I mean, those Artemis programs have provided like some possible locations where they can land. So based on that, only few locations were selected, not the entire. Maybe if the time permits, if we have to do it for the hazard map, then I'm able to do it later.
Okay. Okay. Thank you.
Thank you.
Hello, Minakshi. This is Anandarup here. My question is that in continuation with the last point that Shivapunan was discussing, like the Earth's mantle we know is kind of liquid, right? There are convection currents and what causes earthquakes, movement of tectonic plates. Is that right?
We don't know, like there is, I mean, till now it is not approved that it is due to the plate movement. It is due to like in between the plates only, like it's far from the plate. There are no plates available on the moon, like because of that the seismic activity happened. It's similar to that, like our peninsular India, where there is some zones of weakness in the lithosphere, and because of that such seismic activity is happening.
Right, but what do you think is the main cause that the plates move? On Earth, I'm saying specifically. Why do you think that the tectonic plates move at all?
I couldn't understand. You're asking me like why tectonic plates are moving?
Yeah, so
there are no
on a certain
tectonic
planet,
plates on the moon.
right? So on Earth, I'm asking.
It's due to the stress release. Due to the stress, there is some cumulative stress has been occurred in between those plate movements. So when there is a sudden release of energy, and that time earthquakes are happening.
Okay. Thank you. Nice presentation.
Yeah, thank you. So there is one more question, like for synthetic seismogram, where have you taken the source? What is the possible reason of not presenting the surface waves in seismic record? See, for synthetic seismogram from the literature, the source has been selected. Like a double couple source shows the better representation for the radiation pattern or the how the frequency changes everything. So from that, I have considered. So what is the possible reason of not presenting the surface waves in the seismic record? The surface waves will be in very in a congested way, so we can't able to represent like whether they are the surface waves or some body waves, everything. So it is very difficult to identify what types of waves they are. And the next one, to model, you need a accurate layer profile. Okay, accurate layer profile. Whether any tests have been conducted in literature to get the layer profile? Yeah, by doing some array processing synthetics, by taking some stack of records, they have determined the one-dimensional velocity models. So by like till 1 kilometer, what is the shear wave and the p wave velocity? So like till 1737 kilometers, they have given some velocity profiles. So by from the recent literature, we have considered the velocity model, which is nothing but the modified Vibramon, which you can get from the Garcia et al. 2019 paper. Is there any questions I have to answer?
There are no questions from YouTube.
Okay. Thank you, everyone.
Thank you, Meenakshi.
Thank you.
We move to the next presentation. This is by Anil Kumar from Structural Engineering Division.
Greetings to everyone. My name is Anil Kumar PM. So I will be presenting the topic on investigation on multi-stable variable stiffness composites for morphing application. The work is done under the guidance of Professor B. N. Rao from IIT Madras and Professor R. Olfers from Leibniz University at Hanover, Germany. So the topic is all about multi-stable structures, multi-stable morphing structures. So morphing structures are structures which has continuous shape-changing behavior. These kind of structures are inspired from nature. So we try to mimic nature's continuous shape-changing transition into our basic structural design to produce energy-efficient and multifunctional designs. These kind of structures are usually designed with reconfigurable elements, sensors, and actuators. These are being widely used in aerospace, wind, automobile, and solar industries, where we just try to mimic nature's continuous shape transition into our design regime. So in order to have continuous shape change, we need to go for morphing mechanism. Morphing mechanism will ensure the smooth transition of the shape. So in order to have a smooth transition of the shape, one of the basic requirement is the structure should possess multiple equilibrium positions. If the structure possesses multiple equilibrium positions, we will be able to change from one stable shape to another, another to the third one to the fourth one. So there is a continuous shape changing phenomena happening. So one of the ideal candidate for this kind of structure is bistable structure. In a bistable structure, mathematically, there will be two stable states separated with an energy barrier. So if we are able to give energy inputs to cross the energy barrier, we can change from one stable shape to another and vice versa, which can be used in morphing applications. So one of the conventional example for bistable structure is unsymmetrical laminate. An unsymmetrical laminate, when it is during the manufacturing process, it will be subjected to a high curing temperature. When we bring down the curing temperature to room temperature, this kind of structures exhibit residual thermal stresses, and it has a tendency to show any one of its stable configurations. It is important to note that these stable configurations are orthogonal to each other. Then, these kind of bistable structures are widely used in aerospace structures, reconfigurable structures, solar structures, bionic structures, and other structures like vibration isolation. These have been widely used for the past 3 decades and widely actively researched in the design applications. So now we know about bistable structure. There are two. If there is a laminate which is subjected to a curing process, there will be two stable configurations: stable configuration 1, stable configuration 2. So how to change from stable configuration 1 to stable configuration 2? This process is known as snap through. We have to give energy to cross the energy barrier to change the stable shape. We can do it passively using mechanical loads. We can give mechanical loads to the stable shape 1 to change to stable shape 2. Then we require additional setup for the same. Or we can attach some kind of smart materials to the surface of the laminate, and we can trigger the snap-through process, which can enable from stable shape 1 to stable shape 2. So I will be discussing more about the active methods in the coming slides. And there is excessive amount of research happened from 1981, where Haier was the first one who identified this peculiar behavior of unsymmetrical laminates, to Harder et al. In 2020, one who come with a new techniques for the analysis of such kind of structures. So after doing the literature review, we found that there is a lack of fast and efficient tool for the analysis. In order to design the structure, first we should be able to analyze the structure. So if we are not able to analyze the structure, then the design will be more troublesome. So we need developing an efficient technique for the analysis is of considerable research interest. And there is a noticeable mismatch with the experimental results. We have to find out what's the reason behind this one. And large energy requirements to trigger snap-through. If someone says me that to change from this table shape to this table shape, you need this much excess amount of energy, I won't be preferring those kind of structures. So we need to reduce the energy so that we give small energy inputs to enable the shape transition. So one of the possible method is Halder et al. In 2018 found that usually in laminates, there will be fiber and matrix. These fibers are usually in the straight direction. So if you change this kind of straight fiber to curvilinear fibers, we can reduce the snap-through requirement by 45%. So if you need like 1000 Newton load to change from one stable shape to another stable shape, if you use this kind of curvilinear fibers, you require only 450 Newton. So the 45% of reduction can be obtained without any compromise in the other properties of the design. And then how to change the stable shape? We can use some kind of smart materials to change the stable shape. We can use shape memory alloys. We can attach shape memory alloys to the structure, and we can heat the shape memory alloy, or we can use shape memory polymers. We can use some kind of piezoelectric material to change the shape. But there are many problems associated with this. Shape memory alloys usually get overheated. Shape memory polymers are usually very delayed. They have very too much time-taking process. Piezoelectric materials are usually susceptible to damage. So if you do repeatedly some amount of shape transition, they will get damaged. So as a solution, NASA in association with Virginia Tech came with a solution which is a macrofiber composite, MFC. So macrofiber composites are usually a piezoelectric material, but it is more flexible and high performance. So if you can attach this kind of MFC to the surface of the laminate, give the voltage to it, this voltage will be producing electrical energy, which will be changed to mechanical energy. This mechanical strain will be transformed to the base structure to change the shape transition. So MFCs are one of the most advanced technique for the shape transition, and which can be used at industrial scales. The scope of the thesis is like, so there is a laminate with two stable configuration, and we have an MFC which can be used for the shape change. So the first objective is to develop efficient technique for the analysis. So we need to develop a technique which can be used for the analysis of such structures. Then another objective is how to use MFC activators in the design. So we need to use MFC activators in the design to use the shape changing process. And how to use variable stiffness laminates. I've already mentioned about variable stiffness laminate, the curvilinear fiber laminates, to reduce the snap-through requirements. And finally, a practical application should be demonstrated. So in expected deliverables and methodology, in the expected deliverables, we should be able to provide a quick and efficient framework for the analysis of such structures. We should be able to give a configuration, a multi-stable configuration which require only minimum energy for the shape transition. And finally, a design of a practical morphing application. The methodology is divided into three parts. One is using the basic mechanics principles. So basically, it's a bistable structure. The energy principles can be used. So you can use basically the energy minimization principle, and we can develop a semi-analytical framework, which can be implemented in a mathematical software, Mathematica. Then we can do a numerical framework. You can do a full-scale geometrical nonlinear analysis, which can be done in a finite element software, Abacus. And we can use a experimental validation for the results. In the methodology, so we have two things. One is a semi-analytical model, one is a numerical model. In the analytical model, which is basically from mechanics, we need to assume the displacement polynomial. Then from there, we have to find out stress, strain, force, and moments. From there, we have to find out the total energy of the system, and we have to minimize the total energy to get the stable configurations. In the numerical model, the Abacus model, we can directly model the laminate. We get one stable shape. We keep on giving the energy, give energy until we have to cross the energy barrier. So we have to keep on giving energy, and we will reach the peak point in the energy barrier, and suddenly the energy will be sufficient, which will change from one stable shape to another stable shape. And in the fundamental software abacus, at a time, we can get only one stable shape. We are not able to get many stable shape. We can get only one stable shape at a time. But from the analytical model, we can get all stable shape at a time. The work status is semi-analytical, numerical, experimental studies of variable stiffness laminates using MFC actuators are carried out, and the results from semi-analytical and the fundamental frameworks are in good agreement with the experimental observations. The first objective was to develop efficient framework for the analysis of the structures, which was completed. Second objective was how to use this kind of MFC activators in the design. That was also implemented. Third objective was how to efficiently use variable stiffness laminate into design. That was also implemented. And the fourth objective on the design of the practical application is ongoing at this moment. Concluding remarks are, an efficient framework for the analysis of multi-stable structures using smart materials have been developed, which can be used for the future generation in various morphing applications. So using the design strategy, the energy requirement for shape transition can be reduced by 40%. So if you require something like 1000 voltage for the standard shape transition, using the design strategy, we require only 600 voltage. The 40% of the energy requirement can be reduced. So this is a great advantage in morphing applications. And the future scope is, now we are discussing only about two stable shape, one stable shape, second stable shape. We can have multiple stable shape. We can get 1, 2, 3, 4 stable shape. Then there is a continuous shape transition. The structure can be continuously changed from unstable shape to unstable shape. This is of considerable interest. And design of a practical application is also ongoing process. These are the two future scope. So there are 3 journal publications and 5 conference publications from the thesis. So all details will be available in these websites. So thank you so much for the attention. You may contact me for any clarification. Thank you so much, and thank you.
Thank you, Anil Kumar.
Thank you.
Please post your questions to Anil in the chat box, or else please unmute yourself.
Hello, Anil. This is Shivapurnan. So the question that I have is, what is the motivation for having these two stable states in perpendicular direction? Is there any specific reason why we need to have them in perpendicular directions? Can we also have, because usually we also know stable states where they are just downward sagging and hogging in the same direction, right? So compared to that, whatever you showed, so how is it different and why is it needed?
Yeah, thank you, Shivapurnan. Yeah, actually, the perpendicular stable shapes, it was a naturally occurring phenomenon. Like we did not expect it to happen. Like it was naturally like the unstable laminates usually, because of the stacking sequence in the laminate arrangement, they usually show bistable shapes which are orthogonal in direction. Yeah, but we can tune to change the orthogonal bistable shapes. That is also of considerable interest, but I did not explore that. Yeah, we can explore to tune the curvature.
Thank you. And two other questions I have. One is that is it always a rule that we need to reduce the energy barrier to a minimum? Because shouldn't it be like under the mechanical loads which would be coming in applications, the energy barrier should not be crossed on its own. Rather, we have to willingly apply energy so that it can be transformed at will, right? So there should be a thin line between how much minimum and how much high it can be, right? Is there, what is your opinion on this?
I hope you are asking about passive and active. Like maybe I'll try to answer that question. Like yes, there will be a naturally occurring loads on the surface, so that will sometimes it passively changes from one stable shape to another. So that also has to be investigated. It is in my one of the motivation. So what basically happens is when you try to apply some voltage or try to change the shape, there will be some natural load which try to help. That will be passively helping with the active system. Active system is the piezoelectric material attached to this one. So that will be passive system which will help. So then we are defining like this much energy for causing that moment will be a little bit difficult because that depends upon what are the natural loads coming in the structure. Yeah, that will help in designing the optimum strategy. Did I answer your question?
Yeah, sort of. But what I actually wanted to understand was, let's say, as you gave an example of having 1,000 volt energy requirement for switching the stable states, you could reduce it to 600 volt through the curvilinear path, right? So, if let's say that someone is able to reduce it to 100 or even as a 50, 25, 20, and so on. So the lesser it is it always the better? Or at some point it will get stopped and say no, if you get any lesser than this, during the application itself it will change on its own rather than we trying to change through will.
Yeah, it has two sides. Actually, we can say that lesser it is better in our design. Yeah, it will be nice, like if you consider some kind of passive loading, like for example, if I model a airplane being using this kind of thing, and there is aerodynamic load which is naturally coming into the structure, and okay, that will help me to passively change it. Okay, then the requirement of voltage will further reduce from 600 to 100 also. That is a good advantage. At the same time, if we don't have a control on that one, that can be a more issue. Like it will start vibrating between the stable shapes. So that will create more kind of a flutter kind of phenomena, and it will eventually damage in factory control. So it has both sides. So we should eventually have a control on such phenomena.
Okay, thank you. And the last question that I have is, you had mentioned that the curvilinear path was able to reduce the energy barrier, right? Can you please give a physical reasoning of why that may happen? Is there a specific reason why a curvilinear path is able to reduce the barrier? As far as I understand, perpendicular is having the two fibers, and any direction, any inclination of the fibers is just a component of it, right? I don't know. I am just guessing it. So I'm not able to understand why curvilinear fiber path is able to reduce the energy barrier practically or physically.
Yeah, actually, it's a nice question actually, because it's like when you have a normal laminate, the stiffness is constant throughout the domain. So what happens, like for this kind of structure, there will be axial bending and the coupling stiffness. So that will be constant throughout the domain for normal laminate. But in case of this, if you adopt this kind of curvilinear laminate, these stiffnesses are kind of function of the location. So that whole equation, like the whole phenomena, for stiffness matrix or the first stiffness variation will be just spatially varying. So we can say that for curvilinear laminates, the stiffness is spatially varying. And in this kind of morphing application, like there will be like there will be a point which it initiate the shape transition. So there will be some points which really initiate. So if you adopt this kind of curvilinear fibers, that where the stiffness is less, those points will try to help to change the shape. So naturally, it helps in, but it happens in reverse also. In some kind of curvilinear fibers, the most of the edges will be more stiffened. So there will be more requirement required to push. In some alignment, the edges and corners will be really less stiffened. So it will naturally help me to go to other stable shape. So that is actually happening because the stiffness is all varying over the whole laminate.
Okay, so as far as I understand, so this is like you have optimized the shape for reducing the energy barrier, right? So one other thing what I wanted to ask is, can we also give perpendicular curvilinear, like multiple curvilinear fibers, just like in orthogonal fibers, right? You have two orthogonal fibers in as 4 layers. So is it also possible to do similar thing in the curvilinear fibers, where you can, instead of having only one fiber, you can have multiple layers wherein each curvilinear path is different? What do you think will be the effect if it is possible?
It should be possible. It is not a difficult task. It will be possible. Only thing, it will be little bit difficult if you really try to manufacture. So that is only thing I feel. Otherwise, it's like theoretically it will be possible to model, but in manufacturing constraints, like only aligning two layer with the orthogonal itself, it's a like you require really heavily advanced techniques, but it should be possible, I think.
Okay, thank you. Thanks, Anil. Nice presentation.
Thank you.
There are no questions from YouTube. So attendees, please, if you have any queries, you can unmute yourself and share with Anil. So if there are no more queries, we'll wind up the session. Thank you, Anil.
Thank you.
So this brings us to the end of the first day of PMRF Symposium 2021. So we'll meet tomorrow, 4:30 p.m. in the same link for the day 2. I request all the speakers, whenever you're posting the queries or answering the questions, please switch on your videos. It'll be more interactive that way. So thank you all again for attending and for your active participation. Thank you, speakers. Meet you tomorrow. Thank you.